Welcome, fellow foamboard enthusiasts, to another episode of Foamboard Shenanigans. Today we're diving headfirst into the world of DIY foamboard airplanes, powered using a single 18650 battery. Get ready for an exciting video packed with design tips, build techniques, and the exhilarating maiden flight of our creation. Will a single 18650 battery be enough to power an RC plane? To find out, let's jump right in. I'm starting this build with the Powertrain, because I'm a bit skeptical that a single battery configuration will actually produce enough thrust to work, so I want to test this before committing to the rest of the build. So this is a single 18650 battery recovered from a power tool, so it should have a higher discharge rate than batteries recovered from laptops and the like. The motor controller is a 20 amp DC motor ESC, simply all soldered together. The receiver is a lightweight 4-channel receiver for the FlySky brand, and these work reasonably well over a short range. However, I don't think the 3.7 volts or so of the 18650 battery will be good for the receiver, as this is expecting 5 volts from the ESC. As this is a DC speed controller, it's expecting a reverse or forward signal, so to prevent any mishaps, I'm setting the throttle curve on the radio to 50 to 100%. This motor has a tiny 2mm shaft with no way of positively fixing a propeller to the shaft. I'm using a drone propeller here, as these are the type of props that have a 1.5 or a 2mm hole for the shaft. I'm grinding some flats on the shaft so that I can glue this into place. If the prop needs to be replaced, the glue can be softened with some heat and a new prop glued in place. I number the motors and the planes, as the FlySky radio has space for 20 models, but the text that is used for naming has limited characters and is not quick to use. Numbering saves some of the hassle. So now this Powertrain is ready to go. I start with a dimensioned sketch outlining the wing shape, fuselage length and tail configuration. For this build, I'm borrowing from the 18650 plane designed by Kendon Yap. However, I'm adapting this for a carbon fibre arrow shaft for the fuselage. I'm using this 3mm high-density foam board for its lightweight and durable properties. A steel ruler and square are required for this part, as precision is key when crafting each component of your airplane. I 3D printed the shape of the airfoil, and I'm using this to cut out the wing ribs. If you like DIY builds, you should definitely check out Kendon Yap's channel. I've built a few of his models, and they do not disappoint. I use a thin carbon fibre rod to strengthen the wings and hold the dihedral shape. The rod is heated and bent to give a 7-degree angle to the dihedral. These are the tail pieces for the vertical and horizontal stabilisers. To form the hinge in the 3mm foam, I depressed the foam with a steel ruler and taped over the fold. The design allows for the dimensions in the Kendon Yap build, and you can see the arrow shaft that I use for the fuselage for this plane. I'm forming the curvature of the wing by progressively bending the foam over the edge of the desk and on a thin aluminium rod. To set the dihedral shape and build the attachment points for the arrow shaft, I'm modelling some parts in SketchUp. SketchUp was a free drawing program that could be used to design simple shapes very quickly. I've started with the wing profile I used for the ribs and extruded out a few simple shapes for the centre, left and right sides. These are then grouped and the wing attachment parts rotated to set the correct angle. These parts are then brought together. To attach the wings to the fuselage, I'm using a cylinder with a gap at the bottom, so I can slide this on the arrow shaft and fill the gap with a bit of glue. Again, this is grouped and joined to the main part. Similarly, for the tail section, I've used the same cylindrical extrusion and designed a few features to help locate the vertical stabilizer. There are some simple tabs that I'll protrude through the horizontal stabilizer and keep everything aligned. The two models were then exported as STL files for slicing and 3D printing. The models were sliced in Prusa Slicer and printed in lightweight PLA on a Prusa i3 Mark II printer. Not the latest technology in printers, but more than capable of delivering the quality needed for this type of project. 0.3mm layer heights and a 0.6mm nozzle were used. Minimum wall thicknesses were not set, as the parts are too thin to begin with. These were sliced and printed separately to minimise travel and stringing. With the fuselage, wings and tail sections printed out or cut out, it's time for assembly. I'm using special expanded polystyrene glue for this, as it does not melt the plastic, it's incredibly tacky, and it sets relatively quickly. All of the ribs are glued in, taped into place, and the carbon fibre rod is inserted. I set the carbon fibre rod to the centre part so the wings could build off this at the right angle. This wing build is fairly flexible, but incredibly light. The carbon fibre rod helps a lot. It's just the tips of the wings now flap about. To hold the carbon fibre in place, I used a bit of Gorilla Glue. This will expand a bit and make rounded edges over the transition between the wing and the rod. Not sure if this really helps, but it looks okay. Then the tail section is built in much the same way as the wings, by building onto the 3D printed parts. Here, cutouts are made in the horizontal stabilizer for the protrusions, and the parts are assembled, making sure everything is square. Now we can assemble all of the parts. The tail section and the wing section are slid onto the fuselage, and the electronics are taped into place to get a sense of balance to set the correct CG. Once the battery is in place, it won't be able to be adjusted, so I need to set the CG now. As the battery is the heaviest part by far, this is a bit fiddly to get right. Once I think this is right, the battery tray is cable tied into place. The motor needs to be mounted with a 2 or 3 degree rotation to the right and about 1 degree down. I marked the approximate places on the cutting mat and tried to hot glue, hold and align at the same time. Trusty cable ties are used to hold the motor in place, as I don't trust the hot glue on the metal of the motor. The receiver is then located and sealed in heat shrink to isolate it to the fuselage. Carbon fibre is conductive, so I want to reduce the risk of electrical issues. The last part to go on is the servos and push rods. Here I am keeping the weight down by using 5-gram servos and mounting them as close to the CG as I can. These are tiny and have a very small throw. I now see I should have made an angled mount as part of the 3D printed wing section to attach these two. Setting the correct angle and getting these glued into place was far from ideal. The servos are staggered and slanted to prevent clashes. The control horns are added and held in place with more Gorilla Glue. These have a small amount of adjustment for fine trimming later. Push rods are shaped to fit the fuselage and held in place with a thin straw. And then that's about it. The final weight of the build is 125 grams for the plane and 44 grams for the battery, so 169 grams all up. Nice. Right. 18650 plane, maiden voyage, very windy though. Let's see if we can get it goes. Go. Alright, success. After hours of meticulous planning and assembly, the Foamboard airplane was ready for its maiden flight. It was probably too windy to fly this safely on the day, but I wanted to test it out, so we risked it. There was something quite off about the CG and elevator control that I need to look at before trying this again. Now, I thought that it was a pretty gentle landing after the first flight. However, the horizontal stabilizer was damaged, and this resulted in limited control during the second flight, ending it pretty quickly. But for a plane under 200 grams, powered by an 18650 battery, I would consider this a success. Our Foamboard airplane is a flying masterpiece. Until next time, happy flying and keep those Foamboard shenanigans alive. Thanks for watching.